Mouser Electronics is an authorized semiconductor and electronic component distributor focused on new product introductions from its leading manufacturer partners. Serving the global electronic design engineer and buyer community, its website features more than 5 million products from over 1,200 manufacturer brands. For more information, visit Mouser.com. All right, guys, I'm Nicolette, and today Brian and I are here with Shawn Hymel. He is a senior DevRel engineer over at Edge Impulse, and he's going to talk to us today a little bit about machine learning, some of the new technologies out there, and some data. I have a feeling we're going to talk about some data and other embedded related items. So thank you, Shawn, for joining us today. We appreciate your time.
Yeah, thanks for having me. I'm excited to chat about machine learning on the edge.
Yeah, wow. Why don't you give us a little bit of background? Tell us a little bit about yourself and what Edge Impulse is doing over there.
Yeah, so I'll start with Edge Impulse and then how I fit into that. Edge Impulse is a platform. It's an internet platform or a software as a service platform used to train machine learning models that ultimately we help you deploy them to edge devices. And when I say edge, I think microcontrollers, so things like Arduinos, Raspberry Pis, as well as your phone, mobile, and those type of applications. Anything from accelerometer data, audio data, think keyword spotting like your Echo devices or your Google Home devices to help with smart speakers, as well as our new thing is going to be, or is now, vision. So that includes doing things like image classification to identify things like anomalies, or maybe there's a person in the frame or a face in the frame, to even object detection. And we have a new model that we've developed called FOMO that is constrained object detection that lets you do a basic form of object detection to say, hey, where is the face, or are there multiple faces in a frame?
So are you guys doing it on just images or videos, or are you doing real time?
So training is done all in the cloud. And so you have to upload images to make that happen. Right now, it's just static images. I mean, there are easy ways. I think VLC will let you take a video, slice it up into a bunch of images, and then you can upload it to our studio. That's all done. That's all trained in the cloud. And then inference is where you have the model and then you use that model. So that actually gets deployed to an edge device, and that's all run locally. So you can do all that, identifying where the faces are in the frame without an internet connection.
Wow. Okay.
So Shawn, I know that you are not personally heading over to Embedded World, and by the time this episode airs, we will be after Embedded World. So if you're listening, Embedded World's already happened, and now we are going to talk a little bit about some of the stuff that happened. But I know that Edge Impulse has a pretty big presence there at the show, and I was wondering if you could just give us a little bit of insight into what you guys are really doing with some of those exhibitors out there, maybe how you guys are creating machine learning solutions for edge-based scenarios and products. What's the deal over there?
Yeah, so we've actually partnered with a number of silicon vendors, everybody from Renesas, Sony, ARM, Panasonic, Silicon Labs, Nordic, all of these silicon vendors. They are all wanting to do machine learning, and we help them do that. So that way, when somebody comes to one of these silicon vendors to say, hey, I want to purchase an MCU or millions of MCUs, and I need an easy way to do machine learning, what do you have? We've partnered with them to help their end customers create machine learning models for their own solutions. So we love this partnership because we don't make silicon. We don't want to be in the business of making silicon. We'd rather partner with people who do and make it easy for everyone to train their own machine learning models, because all they have to do is just provide data. We help you create this model and then deploy it to your device.
So what are most of these MCU manufacturers, do you know what applications they're using these in?
Oh my goodness, think of anything that is basically a tiny computer that doesn't have a screen or other interface. So smaller, less powerful than, say, your cell phone. So cars are notorious for having dozens of these microcontrollers in them. So that's a big thing. Your microwave probably has a microcontroller in it, right? Anything that has any sort of smarts or intelligence, that's all of this embedded stuff. I'll use the term embedded world kind of tongue in cheek, but that's the idea, right? Anything without this interface is kind of what's this embedded this embedded genre. So any of those things, right? all of those are good candidates for this. And we've got a
I
couple
just can't wait to see machine learning on my microwave.
Oh, yeah, I don't know what it's going to be used for. Actually, I have a project idea that I've been working on, or just started. I picked up some sensors. They're on my desk here somewhere. I just picked up some sensors. I want to try to create the perfect toast based on smell. Right? I want to determine if my toaster is burning my toast and then cancel it automatically.
Right, just have it pop right out.
Yeah, and then with and then so you can think about I can detect if something's burning using various sensors, and that's pretty easy to do without machine learning. That's just like, do carbon levels rise over a certain amount, right? Cancel whatever. That's actually not too bad. But can you create a perfect toast or perfect insert item, think in your microwave based on the smell, like, that smells done, right? This is, and so you can use machine learning with like maybe regression or something to say, it's going to be done in 5 minutes, or this is the level of doneness based on smell. Therefore, we should stop it. So, I mean, it's kind of ridiculous, but maybe this idea of machine learning in embedded systems can help us in our daily lives.
Yeah, that would actually be pretty cool. You know what you got to do too? You got to program it so it says, because you know how things continue to cook even after you remove them from the heat? So it has to know like a few seconds before, so it gets removed from the heat.
Yeah, that might have to be programmed. That might have to be programmed in, or you train it based on like, okay, I want it to be done 5 minutes for that overcooking period, and then say, okay, be done here.
Yeah.
And that kind of, I was going to ask you a little bit about, machine learning, let's say a decade ago versus now versus, where are we going? Is it really as innovative as, we make it sound, right? And I guess, based on what you're saying, you kind of answer my question. I mean, we really can come a long way, but what are your thoughts on that?
Yeah, we have come a long way. I mean, 10 years ago, we were just seeing the release of that, the Google AI, oh my goodness, I'm forgetting the name of it. It's a brain. What is the brain team? Yeah, the Google Brain. Of course, it's the Google Brain that did the research back in 2010 that showed you could actually make a pretty solid image recognition system by taking all of this data from the internet, right? And that seems silly, but that was 10 years ago. And up until that point, we were kind of considered in an AI winter where neural networks were poo-pooed. Nobody liked them. Classical machine learning methods ruled, like your support vector machines, and they had some limitations where neural networks are computationally expensive, but they can be made to be more accurate because you can layer them and do all sorts of crazy tricks with them. And as a result of these architectures, we're seeing crazy new things. I just learned about DALL-E 2 yesterday, where you can just say, hey, make me a picture of a cat flying an airplane, painted by Salvador Dali, right? And it'll just generate it for you. It's absolutely incredible what we're seeing now.
I've been playing around with some of those photo tools too. Some of them not quite as advanced as others, right? I've gotten some pretty funky images, but other ones have been really, really accurate.
Yeah. Oh, it's absolutely crazy what you're able to do. But from the embedded perspective, it's actually kind of limiting because you're limited by compute power. So I don't expect to see that level of stuff coming out of embedded systems. I believe that what we're seeing, what our capabilities are now for embedded is kind of what you had for larger computers 5 to 10 years ago. And then so the idea is, was it that useful 5 to 10 years ago? Maybe, but then in the embedded space, we're saying, what are some of our narrow scoped niched areas where this would help solve problems? So things like keyword spotting, right? I don't need an embedded system to do full natural language processing and understand every word that's coming out of my mouth, right? We've got big computers to do that. Maybe one day we'll have processors that do it, but right now, you think about your ALEXA device, and I won't say it because I've got one on my desk right here, but like your Echo devices, right? Those just need to listen for one keyword out, and it doesn't care about anything else. And it can do that all on the device itself. And that's an
Right.
That's an example of embedded machine learning where it's listening for one keyword and then it starts streaming to your big servers so that it can do natural language processing, which are much larger, heavier algorithms to do this. So I think it's, the idea of embedded machine learning, we have to scope it to just our problem areas that we're trying to solve, not trying to understand all of human speech, but just one keyword. That's all we need. And the same thing for vision, right? I don't need to identify every object that a camera sees for my embedded doorbell. I just need to know, is there a person, right? That's all I care. So I think that's the use cases for embedded machine learning, where we're just trying to apply it to solve individual problems and making sure our scope matches what we need to get done.
So I guess the question is, right, where, when it's edge-based versus cloud-based, where is the intersection where you're getting enough power when you're, like, say you're an autonomous vehicle, where you're getting enough power at that point where it doesn't have, some cloud-based connectivity, right? Where does it get to the point where it could truly be almost autonomous and disconnected?
I think it highly depends on your use case. And what you're trying to accomplish, right? You think about, I wish I was an expert in autonomous vehicles, and I'm not, so I don't know exactly what algorithms. So some listeners may know better than I do about what algorithms they're using. So I don't know how much of it is cloud-based versus how much of it is local processing on a larger machine inside the vehicle itself. And I'm sure there's some combination of both going on. So it's probably a question of what needs to be done. So things like object detection and recognition, you could probably do that locally. Think of Jetson Nano or something that can actually, handle object detection without a problem at 10 frames a second. Or, in a car, you probably want 30, 60 frames a second. But I could see that happening. But then some of the algorithms for driving, maybe you can do some of it locally, but for your online learning, where you have to push stuff to retrain the algorithms, that becomes a little more difficult. And you're probably not doing that on vehicle. That's things that, I missed a stop sign. I should have seen this. Now I have to retrain my algorithm. So it has to send this data to the cloud to retrain the model to come back to you for inference. So usually that's kind of where your divide is, at least right now, is most of your training is done in the cloud. Most of your inference, at least for embedded stuff, can be done on device, depending on your use case. Things like object detection gets a little more computationally expensive, even from the inference side.
So I think I just need a little clarification. You explained kind of what Edge Impulse is doing over at Embedded World, but how does the company actually, what is your role? Maybe break it down for me. I'm not an engineer, and I'm,
Sure.
My, dog. So help me out here.
Yeah, I actually didn't answer that question from earlier. We got, so involved in talking about AI and machine learning. So my role as a DevRel engineer is I make demos, I make workshops, I make educational material and content that helps people learn how to do embedded machine learning, and more specifically, how to use Edge Impulse as a tool. That involves going to events, running workshops, creating YouTube videos, appearing on podcasts, writing demo application and code, writing blog posts, writing tutorials. So it's a lot of content creation and outreach. And then there's also the other side of it, where, because I'm on the front lines, working with other developers and newcomers, I see where some of their sticking points are. I learn about, what issues they have, both with the tooling, maybe some backend stuff. And then I take that back to the engineers and say, hey, here's what I'm noticing. Here's some common themes that I'm noticing where developers are getting stuck. Maybe we should prioritize either fixing a particular bug, or we need to change the interface to look like this because they're getting hung up here.
Okay. So what do you find? Sorry, Nicola, were you going to ask a question?
No, I understand.
So, what do you find is the best way that people start understanding or to teach machine learning?
That is a good question. I came up through the math route, but I don't necessarily think that's always the best, right? Do you need to understand how a car works to drive? And the answer is no, of course not. So I came up to the math route because I like it. I enjoy it. I took Andrew Ng's class on Coursera, and I think it's one of the best, if not the best, online course you can take for machine learning, because he goes through the math. That being said, something like Edge Impulse or any of these other very graphical services that you can online that you can use help a lot. If you just want to tinker around with training your own models, right? Edge Impulse is just, you give it a bunch of data. We've got a number of tutorials that say, hey, get this data. It might be a collection of keywords. And a lot of times they're just WAV files. You can double click on them, open them up in your computer and be like, oh yeah, this is somebody saying ALEXA, right? This is just audio. And then I take that and I bring it into my studio project. And then it walks me through the process of, there's a DSP portion that you don't have to understand. And just, hey, we recommend for keyword spotting, we transform all the audio, the raw audio, to look like these particular this particular type of data, right? We get spectrograms and things that kind of look like images. And then here's a neural network, and they'll show you what the layers are, but you don't need to understand what each of those does. So you just click train, and you get this nice little box to say, oh, am I pretty accurate? And then you can test it. You can deploy it to a device if you want to try it yourself, or there's, at least for Edge Impulse, you can just try it right on your cell phone. Like, oh yeah, let's try keyword spotting. I just trained a model, let's try keyword spotting. So you don't need to understand the math to use a lot of these tools, which is really nice. So you can kind of black box it away. From the sake of, if you really want to create something efficient, especially in the embedded world, you probably need to know a little bit about it. So you don't just go throwing a bunch of neural network layers on something, not knowing what you're doing, in the hopes of creating something that's accurate, because it won't necessarily be efficient. So I think for efficiency, you got to know a little bit of the underlying math, of the underlying code, what's going on. But for the sake of just using and creating something, just to start understanding what machine learning is, yeah, there's a lot of tools out there that you can have fun with.
So I wanted to ask you a little bit about TinyML, because I came across this I had never heard of it. Again, I'm not an engineer, so I had not heard of this TinyML, and I had done some research, and I really wanted to just ask you a little bit about what is it about? What is TinyML, and how is it unlocking some of those new possibilities in various industries?
Yeah, and I think it's a lot. Some of the examples I gave earlier for like keyword spotting. So being able to interact with computer and computing devices like your smart speaker, that's a big one that's, kind of invisible. But if you've ever done Hey Siri or ALEXA, then you've interacted with TinyML, because that's all running inference locally on an embedded device. Things like these new doorbell cameras that can identify people in frame. I'm pretty sure they're not streaming live video to the internet all the time, because that's a lot of bandwidth. So to save your Wi-Fi and to save your energy bill, a lot of that's being done locally on device to say, oh, this is a person in the frame. So that's another example that you're probably seeing. Something else is, I think it's going to dovetail very nicely with this, what's coming for IoT, right? IoT promised refrigerators that could reorder groceries for us, and we still haven't seen that yet. But we're seeing IoT both in the homes, in the sense of smart speakers, and the big place where it's kind of invisible to consumers is industry. So think machines, factory lines, where you can put these sensors to determine things like output, waste, issues, errors, how well is this machine performing? Those kinds of things, and they show up as dashboards on, a line level manager system to be like, yeah, here we're seeing all these things and we can get all these metrics, even things like temperature, we can report all these things. And right now it's just showing up as a dashboard and saying, hey, it's up to you to figure out what these lines and graphs mean. But with machine learning, we can actually start doing a lot of that on device. And rather than just streaming data all the time to a dashboard, the devices, the sensors themselves will start being able to make predictions, make classifications to say, oh, I'm not going to report anything unless there's a problem, right? Oh, your boiler is now above what it should be. Let's push a notification to our manager or safety supervisor to say, hey, there's something wrong. You need to check this out. And then we get into this idea of predictive maintenance, where we can do things like measure the vibration, measure current usage, look for anomalies, either through like the infrared spectrum or through a camera, listen for anomalies like, oh, that motor doesn't sound right. Think about having a sensor in your car, and rather than calling into the car guy's talk show and being like, oh, the car's making a clunking noise, like having a sensor that says this clunking noise means this. And if you don't get an error code, it can listen for a particular noise and say, you probably need to take your car in before something really bad happens. happens. And so that's getting to this idea of predictive maintenance where, maybe it's just one part they have to replace and it's $100, but if it fails, your whole engine breaks and now it's like a $3,000 repair. So let's try to repair equipment or get notified that we need to repair equipment prior to it actually breaking. And so the promise here is with things like predictive maintenance using machine learning along with IoT, we can go into industry manufacturing lines where we've got these $1 million robotic systems, these $1 million setups for doing production. And with small, fairly cheap sensors, we can say, oh, we think something's wrong in this section. You need to go check it out and perform some maintenance before it breaks and costs you $1 million.
We were having this conversation, Brian, recently with Amran about some of the predictive maintenance and the sensors and whatnot. Yeah. And one of the questions you asked, which actually inspired me to start thinking about it for today, was about visualizing the data. And I was wondering if maybe we could repurpose that question because I thought it would be really cool to talk to you, Shawn, about that.
Yeah, and there's a number of ways to visualize data. I'm sure Brian can talk a lot about that because you work in the data. I do data from the sense of ingest it. Let's figure out how to deploy this system once we've trained it. I mostly do the embedded side of stuff. So I know a bit about training machine learning models, but it's mostly like, hey, how do we deploy them? But from the visualization standpoint, do we visualize the output of inference because something's already made that decision? Do we visualize the raw data because we want to see that? And maybe we do, maybe we don't. We can also visualize data during the training process to determine if something's wrong with our model. And that can be a big one. So something Edge Impulse does is when people insert data and we generate the data prior to training the machine learning model, our post-process data, the DSP data, we have a visualizer built into the system that uses the UMAP algorithm that takes it, because it could be many dimensions, think hundreds of dimensions, which you can't fathom in your mind, and it does some fancy math to compress it down to 2 or 3 dimensions. So what you can do is you can start seeing it where these groupings of data start to appear. And that'll give you an idea of if a person can identify the different groups, then a machine can likely do that too. So that's very helpful in machine learning, is to visualize where these groupings occur if I want to do classification. So that's another good way. Then the other wonky thing I played with I have a Coursera course on both introductory to embedded machine learning using Edge Impulse, as well as computer vision with embedded machine learning. Both of these are on Coursera if anybody's interested. But in one of them, we play with saliency maps. So you can run an image through a machine learning model that you've trained to classify the image. And then it gives you a heat map showing where the neural network was looking to try to make its decision.
Find it.
Yeah, so these are super cool because a lot of times it's a black box for I don't know, it goes through some processing layers.
It just does stuff, yeah.
Yeah, it spits out a classification. So being able to visualize what it's trying to do is very helpful.
That's actually pretty cool. I mean, what's interesting is, and we'll just use I don't know, we could use a really simple example, right? So you have some equipment that's visually monitoring a piece of equipment, right? And it detects whatever there is, maybe it's picking up audio or noise or something's out of whack, right? Now, so it sends that to the engineer or whoever may work on that machine. But it's interesting too, because, eventually it's going to go, well, this is a squeak versus this is a squeal versus this is, and the squeal means whatever, it's out of oil or it's low on oil, where the squeak means the part's about to break. And I think the visualization of that type of stuff, becomes really important to them. What is it? Not just hey, there's something wrong, right? What does it actually mean? What is it telling me to go fix or go look at in particular?
Yeah. And I think that's one of the big issues with both identifying issues and predictive maintenance, like we were talking about, is one of the big problems we run into is kind of every site and every environment's unique. It's hard to train one model, right? As opposed to vision, where I want to train a model that identifies dogs. And so okay, I can feed a bunch of dogs to it, and it, ideally knows always what a dog is if I feed it a dog image. Right. But this is, the squeak versus squeal in one warehouse, that sounds like a squeak, and in another, because of the echoes, that sounds like a squeak.
Right, exactly.
You don't know.
Yeah. Or is it some guy pushing a cart down that has a squeaky wheel and it's mimicking my machine because it's at the same frequency?
Yeah.
It's interesting.
So that's where it loops into both predictive maintenance and machine learning ops, where I can deploy a device and I need to say, this is what my environment is, and it needs to update the model basically after deployment in order to say, okay, this is kind of what normal looks like in this particular environment. So that's ML ops. And then so something else like Edge Impulse has is we have a whole web-based API. So you can actually push data to a project, update your model, retrain your model, download your model. Now it's kind of on you to figure out how to do over-the-air updates because every embedded system is different. If they even allow for that, right? You got to have like a bootloader with, can you load from the internet or how do you push to it? That's a different story.
Yeah, especially at the MCU level,
Yeah, and there's a number of IoT frameworks out there. I think Azure might do it, but there's a number of them. If you're running like their library or their particular framework on an embedded device and you're using their IoT backend, like they can do over the air. Like Particle definitely did this for their stuff. You can definitely do over the air updates.
It's pretty cool.
Yeah.
Brian, do you have any other machine learning questions?
No, I think we covered a lot today.
Shawn, is there anything else about machine learning and embedded systems and all of this that's going on that we didn't ask that you feel is really important and we should be asking about?
Yeah, I think the idea of, where is this going? That's it. We talked about what is it 10 years ago, but what's it going to look like 10 years in the future? And I don't have a great answer for that, but but it's a useful rhetorical question, right? Can anybody predict the future? Well, of course not. But did anybody
maybe the machine learning can if it
True.
It can try. It can try. So I personally view, to me, it feels like the early days of computing. Not that I was around for that, but like the 60s and 70s where people were tinkering and playing and coming up with these interesting use cases for computers. Like it feels like that. To be honest, for the embedded world, it's probably closer to the digital signal processing revolution in the 80s, where this idea of like, we can do signal processing. We don't have to create analog electronics to receive or send radio waves. We can actually do it on a microchip. Was completely bonkers at the time, right? Like, why are you doing this digitally? This is ridiculous. And now it's like, in your phone has one. Everyone has a DSP if you're working with radio waves. Your car probably has one. We don't need big analog electronics to do this anymore. So it feels kind of like that. Not that we were trying to replace analog electronics, but that we're enabling use cases for embedded systems that were never available to us. This problem space, embedded can solve here, but if we add machine learning, we can now solve other things, like this idea of keyword spotting. I constantly go back because it's a great example. That was really difficult to do simply because how do you spot a known keyword? Like I could try to code it at certain frequencies, but then how do I enable it for different types of voices and different accents? Like it was nearly impossible. So we just never thought about doing something like that. So I think there's lots of opportunities around what machine learning can add to the embedded space, but I don't think it's going to replace normal deterministic programming, right? People are like, I'm not going to use them because I don't know if it's going to work or not. Well, yeah, that's why you have deterministic, our normal just write a program that always does the same thing in sequence. It won't replace that. It's just going to allow us to accomplish different things, which is really interesting.
Right. Or recode the programming to do more than one thing.
Yeah, exactly. Handle other use cases, either you trained it to, or ideally you trained it to. I was going to say you didn't foresee, but if once we get to that level of machine learning, I think that's a new era, right?
Yeah, absolutely.
That's the prediction thing, Nicolette, that you were talking about, right? Can it predict the future, right?
Yeah.
Can it predict things we didn't foresee? Like, we're still not quite. I don't think we're quite there yet with machine learning, but maybe one day.
Yeah.
Well, Shawn, we thank you for coming on and joining us today to talk about this. I was thinking, all right, can you let everybody know where they can learn more about Edge Impulse? If there's anything you guys are working on right now that you want to tell us about, please do so.
Absolutely. So check us out, edgeimpulse.com. You can, there's a free version for developers. Try it, play with it. We've got a bunch of tutorials. You don't even need an embedded system. You can do a bunch of tutorials on your phone just to give it a shot because it's really fun. We also are going to be at Embedded World 2022. So edgeimpulse.com/embedded-world-2022. We will be on site. There's going to be a panel with our CTO and co-founder, Jan. We are going to be at a number of booths because we're helping the silicon vendors. You can also feel free to schedule a meeting with us if you want to chat to an Edge Impulse person there. So that website I just mentioned, we'll be there. Come chat with us. I personally won't. I'm actually at another conference on those exact days. I'm in a conference in the US for education, but there will be Edge Impulse people there.
Awesome.
Very cool. Thank you for joining us today, Shawn.
Thanks, Shawn. We appreciate it.
Absolutely. Thanks for having me.